So in this video, we're learning how to enter these three matrices into our calculator. So the first example that we're going to do is we're going to learn how to do that, put all three matrices into the calculator. Then we're going to discuss adding matrices using the calculator. Example 3 we'll discuss subtracting matrices. Example 4 will be discussing scalar multiplication. Example 5 will be matrix multiplication. Example 6 will be putting all of these previous ideas together, and then finally example 7 will be discussing how to find the inverse matrix. So let's go ahead and start with example 1. We're going to go ahead and put in all three of these matrices into our calculator. So let's go ahead and pull that up. Now to start putting these matrices into our calculator, we need to go to the matrix menu. So hit second and then matrix. And you can see that I already have some stuff entered in, so I need to change this. So I'm going to put in matrix A, B, and C, just like I had before. So I'm going to scroll over to the edit menu, and notice it looks almost identical to what we just had. I'm going to edit matrix A first. Matrix A was a 2 by 2, so the first number here tells me the number of rows, the second number tells me the number of columns, and all of these numbers in here are my elements. So I know my matrix A was a 2 by 2, so I need to change this to 2 rows by 2 columns. Now it's just a matter of entering in each one of my elements. So I'm going to do that very quickly. Okay. Now I need to go in and enter matrix B. So again, second matrix. I want to change matrix B, so I go to the edit menu and I scroll down to matrix B. Matrix B had 2 rows of 3 columns, so I need a 2 by 3 matrix. And I need to put in all of the elements. And it's pretty quick to do this once you get the hang of it. Just be careful that you do not make a mistake. Okay, so now we're done with matrix B. So finally, let's do matrix C. So again, go over here on your calculator to second, and then matrix. And we want to go change matrix C. So we go back to the edit menu and matrix C. Matrix C was also a 2 by 2 matrix, so had 2 rows and 2 columns. And it was just filled with 1s. In every element. So now that we have all three of our matrices entered into the calculator, let's go back to the main screen. So I'm just going to hit second and quit. If there's anything up in here, go ahead and just clear that out. I don't have anything, but you might. And let's discuss how to pull up these matrices onto the main screen. So just go back to your matrix menu, so second matrix. And just right here on the very first menu, let's say I want to pull up matrix A, so I'll just hit enter. Now it's got square brackets around the capital letter A. So hit enter again, and we can see it's the exact same matrix that I entered. So now we finished discussing how to enter all three of those matrices into the calculator. The process that's this process regardless of how big the matrix is. So let's move on to example 2. We're going to find A plus B, A plus C, and C plus A. And here, the big idea is that addition is commutative. So let's go ahead and go back to our calculator. Again, we're finding A plus B, A plus C, and C plus A. Okay, so let's go ahead and clear this and clear out our main screen. And we want to first find A plus B. So go to second matrix. And just like we just learned, we're going to pull up our matrix. So matrix A. We want plus, so just hit the plus sign, pretty easy. And matrix B. So go back to second matrix, pull up matrix B, and now hit enter. But unfortunately, we come up with this error, dimension mismatch. Well, what we learned in class is to be able to to be able to add 2 matrices together, or to be able to subtract 2 matrices, the dimensions have to match. Remember, matrix A was a 2 by 2 and matrix B was a 2 by 3. So we can't add the corresponding elements, so the calculator's not happy. So we're just going to quit. So a plus b is not possible. So let's move on to a plus c. So go back to matrix, second matrix. We want matrix A plus matrix C. And there it is. Remember, when we add matrices or subtract matrices, we just simply use the corresponding elements. So the upper left goes with upper left, bottom right goes with bottom right, etc. Both matrix A and matrix C were 2 by 2 matrices, so this is possible. So here, this new matrix right here represents the sum of matrix A plus matrix C. Now finally, let's find matrix C plus A. So second matrix. And we want C plus A. So C plus matrix A. And you notice that we get the exact same answer. So, as I said earlier, matrix addition is commutative. The order that we put our matrices in when we added did not matter. Alright, so now we've completed examples 1 and 2. Now let's move on to example 3. We want to find A minus B, A minus C, and C minus A. And here the big idea is going to be that subtraction is not commutative, meaning the order does matter. So let's go back to our calculator. We're first going to find A minus B. So let's go ahead and clear what we just did. And we want to find A minus B. So second matrix, A minus B. And hit enter. Well, now again we run into the same issue. Matrix A was a 2 by 2, matrix B was a 2 by 3. So recall, anytime we add or subtract, we have to have the matrices having the same dimension. So let's go ahead and quit out of here, so we're not going to be able to do this at all. So let's move on to A minus C. So second matrix. So A minus matrix C. And hit enter. So this matrix right here represents the difference between matrix A and matrix C. Matrix A was a 2 by 2, matrix C was a 2 by 2. So again, we just subtract corresponding elements. The upper left is subtracted from the upper left, bottom right is subtracted from the bottom right. Okay, so let's go and try matrix C, or matrix C minus matrix A. So second matrix, and we want C minus A. Both matrices are 2 by 2, so we should get an answer. But notice we do not end up with the same matrices. This matrix has a -1 in the upper right hand corner. This matrix has a +1 in the upper right hand corner. So what this tells us is that subtraction is not commutative. All that simply means is that the order does matter. Okay, you have to be very specific on the order when you subtract matrices. Now finally, if we're given a scalar, we're in example 4, if we're given a scalar, let's just call it 2, then we're going to find 2 times A, 2 times B, and 2 times C. So let's go back to our calculator. Let's go ahead and clear out what we just did. And we want to say 2 times matrix A. So we could hit the multiplication symbol, but we don't really need to, so I just want 2 times A. Enter. And there it is. Recall that matrix A was 1, 0, 1, 1. And scalar multiplication, all that is kind of the distributive property. Each element inside this matrix was multiplied by the scalar, which in this case was 2. Let's find 2b. So we want 2b. So just pull up matrix B. And there it is. And then 2c is going to be very similar. Recall matrix C was just a matrix full of 1s. So we want 2c. That's it for scalar multiplication. Very, very, very easy. This process would work even if your scalar was a decimal, a fraction, or a negative number. Okay. Now for example 5, we're going to be discussing matrix multiplication, and the big idea here is that matrix multiplication is not commutative. So first we're going to find a times b, b times a times c, and c times a. Okay, so let's go ahead and get to it. So what I'm going to do is just pull up my calculator first. Go ahead and clear out all the stuff that we've already done, and we want to find a times b first, so let's do that. So second matrix, and we just want a times b. Again, there's no need to put the actual hit the multiplication button. Your calculator recognizes a times b as just being this, just like as if we had two variables sitting next to each other. So go ahead and hit enter, and this is it. Okay, so remember we would have to use that pattern that we discussed in class if we wanted to do this by hand. If you want to, you can verify this by doing it by hand if you wish, but this is fine. Alright, so now let's try b times a. So just pull up matrix b, then pull up matrix a. And notice that we have a problem. We have dimension mismatch. Remember that the first matrix has to have the same number of rows as the number of columns in the second matrix. So that does not happen here. Matrix B was a 2 by 3, and matrix A was a 2 by 2. So the inside of our numbers do not match. So we are not able to do this. So we're just going to quit. So let's go on to a times c. So matrix A times matrix C. Just pulling up both of them like we've been doing every time previously. So to find the product of A times C, just hit enter. That's fine with 1, 1, 2, 2. Well, let's find matrix C times A. See if we get the same thing. So pull up matrix A. And notice we get something completely different. So here, this matrix represents the product of A times C, where this matrix represents the product of C times A. They're obviously not the same matrix. So what that means is that matrix multiplication is not commutative. So be very careful when you're multiplying. The order does matter, so be very specific. So now we're on example 6, and we would like to find 2 times the product of matrix A times matrix B, and then subtract off matrix B. So we're kind of putting all of these ideas that we've talked about previously, we're trying to put everything together. So let's do that. So we want 2AB minus B. Let's clear out what we've got. So all we're going to do, it's very easy, just type it in exactly the way it looks. So 2 times matrix A times matrix B minus B, exactly the way it looked. And there it is. The calculator takes care of everything for you. Whereas if we were doing this by hand, we would actually have to do, alright, well, scalar multiplication, 2 times A. Then matrix multiplication, A times B. And then we would have to subtract off matrix B. It's possible to do it by hand, it just would be a very long process. So to here, the key is just type it in exactly the way it looks, and you can't go wrong. Now finally, in example 7, we're going to try to find A inverse, B inverse, and C inverse. Notice the notation. A inverse has like a -1 raised, it's raised to the -1, B's raised to the -1, C's raised to the -1. That doesn't mean a flip, use the laws of exponents, okay? Remember, there's no division allowed when we're talking about matrices. So this is just a notation that means A inverse, B inverse, C inverse. And we have 2 big ideas for this example. First, inverses are only possible for square matrices, so keep that in mind. And big idea number 2 is that the inverse only exists if something called the determinant is not 0. For more on what the determinant is, you just need to Google that. That doesn't really mean a lot to us. I can show you how to do it. In fact, I will. I'll show you how to find the determinant, but just remember that the determinant cannot be equal to 0. So let's go ahead and pull up our calculator. And again, clear out what we want to find. We want to try to find A inverse. So I'm just going to type it in exactly the way it looks. So pull up first matrix A. And I want that -1 power. So right here, there's a key right below the math button where it says x to the -1. That's what I'm going to hit. And then just hit enter. Looks like A inverse. So this matrix represents A inverse. And we can verify that's the inverse of matrix A by simply multiplying them. Remember, if we multiply a matrix with its inverse, we should get the identity matrix. So let's do that real quick. So I want to say matrix A times its inverse. Okay, so matrix A again. I want to pull up the A inverse, so I'm going to hit that button that we just did. And I get the identity matrix. So yes, those two matrices are inverses. Alright, so now let's try to find the inverse of matrix B. So all I want to do is pull up matrix B first. And then I'm going to hit my inverse button, which again is located right below the math button. Okay, so hit enter. So now we have an error, invalid dimensions. Recall that I just said a few minutes ago that the inverse is only possible if we have a square matrix, meaning the same number of rows and the same number of columns. So like a 2x2 or a 3x3, 4x4, something like that. Unfortunately, matrix B is a 2x3, so that is called a rectangular matrix. So there's no inverse for rectangular matrices, so we can't do this. So let's just quit. Alright, and then finally, let's try to find the inverse for matrix C. So pull up matrix C. And we want to hit our inverse button like we've been doing. And now we have another error called a singular matrix. What this means is that the determinant of matrix C is 0, and that's bad, okay? We can't have the determinant of matrix C to be 0. We could actually verify this, so let's just quit. And to find the determinant of any matrix, let's just do it for matrix C though. We go to our matrix menu, second, matrix, and scroll over to the math menu. And the very first option right here is DET. So let's pull that up. That means determinant. Okay, so now let's pull up matrix C, because we want to find the determinant for matrix C. Close your parentheses, and then hit enter. Well, the determinant is equal to 0. Now, if you're interested in what does the determinant do for us, just go and Google that, determinant of a matrix. In a nutshell, all it does is the determinant is used in finding the inverse of a matrix. It's one option to find the inverse of a matrix. And we actually divide by the determinant. So as we know, we can never divide by 0. So that's what's going on right here. Alright, so in our next video, what we're going to discuss is how we can use matrices to solve systems of equations.